We're going to look at the idea of level curves, sometimes called contour curves. And these are going to be two-dimensional relationships that exist as sort of like the cross sections, if you would, of our three-dimensional functions. So essentially, all we're going to do is we're going to set the function equal to some sort of constant k, and then we can get a relationship in two variables as opposed to three variables. And that's going to tell us what some of the level curves might look like. So one of the things I generally do is to be able to figure out what the level curves look like, I just start by letting k be equal to something like 1, 2, 3, etc. and just seeing what the level curves look like for that. Now, as you can see, let's say we have this paraboloid right here, and you can see that the cross sections of this elliptic paraboloid that's concave down looks like it's going to project circles onto the xy plane. And so every function, essentially every function, has level curves. The question is, what do those level curves look like? Another suggestion might be, why would we even be interested in level curves? I mean, obviously we're interested in what graphs look like because we can try to find zeros, or we can try to find key characteristics of the graphs that can help us with other applications. But what would a level curve help us with? So in topographic maps, a lot of times we're able to look at varying landscape structures, most often the heights of those landscapes. So for any of you that like to go hiking or skiing or anything like that, topographic maps are usually used to be able to try to figure out, or try to denote different sectors of the different heights of mountains or different deserts, even valleys, etc. in those. Even if a heat or the temperature changes across the plate or something of that nature, we can have isothermals. Okay, if anybody's ever seen like infrared goggles, there's usually red that seeks in on the hottest parts, and then as it gets a little bit cooler, it becomes orange and then green and then yellow. And so that basically is a level curve or a contour curve that just has different designated colors at different temperatures. And it's the same thing with the idea of a contour curve, is that as that gets a little bit deviant from the heat source, then we're going to change the colors in that. So just two basic examples of this. I found a pretty good resource, another GeoGebra website, to where you can kind of see what the level curves look like and change with the shape of the 3D object. So in this video, what we're going to do is we're just going to find the level curves analytically, and then after that I'm going to have a video that shows how to try to find the level curves geometrically by using this GeoGebra site. So let's just take a look at some really basic examples. So we're going to find the level curve for each function, and then we're just going to plot a few of them on a graph in two dimensions. Right? So we have this x plus y over x minus y. So here's what we're going to do. Let's start by just saying k is equal to x plus y over x minus y. And we can very easily solve. Okay, so that means that kx minus ky is going to be equal to x plus y. If we subtract x and add ky to both sides, we get kx minus x equals ky plus y. And what we can do is we can factor out an x and a y from both sides. And so finally, if we solve this for y, y is going to be equal to x k minus 1 over k plus 1 is equal to y. And of course the question is, well, what is that? Well, clearly it's a line, passes through the origin. Okay, 0, 0 is a point on every single one of these. And the slope of this line is k minus 1, k plus 1. Right? So just to illustrate what a few of these might look like, if k is equal to 1, that means that we have y is equal to x 0 minus or 1 minus 1 divided by 1 plus 1. And we can see clearly where this is going. Or in other words, y is equal to 0. So that's one of the level curves. if k is equal to 2, that's going to lead to y equals x times 2 minus 1 over 2 plus 1, or y equals 1/3 x. And let's say k is negative 2. K doesn't necessarily always have to be positive. All right? So if that happens, then y is going to be equal to negative 2 minus 1 divided by negative 2 plus 1, or y is going to be equal to and there's an x in there, excuse me, and that means that y is going to be equal to 3x. All right, now there could be some negative slopes, like if k were a half, then it would be negative. All right, so a couple of these level curves would probably look something like this. Okay, so we have a slope y equals 0. That's just a flat line. I'm going to draw these in orange. So this is one of them. And then we had y equals what? 1/3 x. So really not so steep. And then we have y equals 3x, which is a pretty steep line. That's terrible. It should be going through the origin. There we go. Just pretend that goes to the origin. And so that's a few of them. All right. When I show you the GeoGebra app, we'll see a lot better graph than this. A second example. This one's going to be f of xy is going to be equal to x squared plus 4y squared. So let's have k equal x squared plus 4y squared. And again, what we could do is we could replace k with 0, 1, 2, etc. All right. But most of us would recognize this as not as a family of circles, but a family of ellipses. And just to give you an idea of what these look like, let's say k was equal to 1. That would give us x squared plus 4y squared. And here's what it would look like on our two-dimensional plane. Right? Some points that satisfy this would be plus minus 1, 0, and then 0, comma, plus minus 1/2. And that's just by inspection. All right. Hopefully you understand how I got that. I just basically substituted 0 for y, solve for x, substituted 0 for x, solve for y. All right. So our first ellipse might look something like this. I know it's not going to be all that good, but so that's our first level curve. Right? Another level curve. Let's let k be equal to 2. So if k is equal to 2, then we have the point if y is 0, that means we would have 2 equals x squared plus 4y squared, excuse me. So we have plus minus root 2, comma 0. And then if for some reason y were 0, or x were 0, excuse me, that would give us 1/2, or square root of 1/2 plus minus. All right. And square root of 2 is a little bit bigger than 1. So square root of 2 is 1.41. So if I was to plot it, maybe like right in the middle here and here. And then square root of 1/2 is 0.707. So maybe pretty close up here. So if I were to guesstimate what our other ellipse might look like, maybe something like that. All right, I know that's not too good. Let's try again. Probably no better this time. Okay, a little bit better. And we could go on from there. All right, so you could probably figure out another one, but that's what some of the level curves might look like for this structure. One last example. F of xy equals 9 minus x squared minus y squared. So let's let c, or let's just say k equals 9 minus x squared minus y squared. This one's a little bit trickier to try to see what the level curves are. So what we're going to do is we're going to solve, and we're going to isolate x, y to one side and then constants to the other. So x squared plus y squared is going to be equal to 9 minus k. Right? And remember, this is just a constant. Okay, so constant. And so what we end up with is we end up with a family of circles, since x squared plus y squared is r squared. And the radius of the circle will be the square root of 9 minus k. All right, so let's say k was equal to 1. So that would be x squared plus y squared is equal to 9 minus 1, which is 8. So we end up with a circle of radius root 8. And square root of 8 is a little bit less than 3. That's 2.82. So if I was to graph that, right, we probably have something. And again, imagine this is a circle. I know it's not a good circle. All right, but that's about what we have if k was equal to 1. If k were equal to 2, then we would have x squared plus y squared equals 9 minus 2, which is 7. And so we get a circle that's just a little bit smaller with respect to the radius. So again, just imagine if k were equal to 3, etc., we would just keep getting these concentric circles. All right. Now I want you to notice the smallest value of k that could be possible would be 9, right? Because anything less than that would mean, or anything bigger than that would mean that we would end up with a negative value. And we know that the domain, or we know that anything that's under this radical would have to be bigger than 0. So essentially, x squared plus y squared has to be bigger than 9, or smaller than 9, for this to be able to work. In the last video for this series, I'm going to show you how to use the GeoGebra app to look at what these different level curves look like.